Tonight on The Sleepy Scientist, we're drifting gently through the vast cosmic ocean, where time moves like honey through starlight, and the mysteries of our neighboring worlds unfold with the patience of eternity itself. In the quiet space of tonight's journey, we'll explore one of the most fascinating and peaceful predictions about our rusty neighbor, Mars, a world that may, in the distant future, don a crown of rings as beautiful and serene as those that grace mighty Saturn gently. We discover that the universe holds surprises that unfold not with dramatic fanfare, but with the slow, methodical rhythm of cosmic clockwork. Like whispers in the night, scientists have been studying the orbital mechanics of Mars and its two small moons, Phobos and Deimos, and what they've found is both remarkable and deeply contemplative. The red planet, which has captured human imagination for millennia, may be destined for a transformation so gradual and peaceful that it would take 50 million years to complete, a mere moment in cosmic time, yet longer than the entire history of our species. As our journey continues into this realm of scientific wonder, we find ourselves floating through concepts that bridge the gap between the immediate and the eternal. The story of Mars' potential rings is not one of catastrophe or destruction, but rather of natural transformation, the gentle recycling of matter that characterizes so much of our universe's quiet activity. In the peaceful darkness of space, gravitational forces work with infinite patience, slowly but surely reshaping the architecture of worlds. Let's drift into the fundamental understanding of what planetary rings truly are, and why their formation represents one of nature's most elegant and tranquil processes. When we gaze up at Saturn through a telescope, we're witnessing the result of cosmic forces that have been at work for millions of years, creating structures so delicate and beautiful that they seem almost too perfect to be real. Yet rings are not rare in our solar system. They are, in fact, a natural consequence of the gravitational relationships between planets and their moons. A cosmic ballet performed in the silence of space, in the quiet space of our solar system, for planets currently wear the gentle ornaments of ring systems. Saturn, with its magnificent and prominent rings, serves as the most famous example, but Jupiter, Uranus, and Neptune each possess their own subtle ring systems, discovered only through careful observation and the patient work of spacecraft. Exploring the outer reaches of our cosmic neighborhood, these rings tell stories of moons that venture too close to their parent planets, of asteroid captures, and of the ongoing process of planetary evolution that continues even now, invisible to our daily lives, but constant in its cosmic persistence. The physics behind ring formation operates with the same gentle inevitability that governs all celestial mechanics. When a moon orbits too close to its planet, it encounters something called the Roche limit, a boundary where the planet's gravitational forces become stronger than the moon's own gravity holding itself together. This isn't a violent destruction, but rather a peaceful dissolution, where the moon gradually breaks apart and spreads its material into a thin, elegant disk around the planet. The process unfolds over thousands or millions of years, as patient as the sunrise and as inevitable as the tide. Now we float toward the specific case of Mars, a world that has fascinated humanity since ancient times, when it appeared as a wandering red star in our night sky. Mars today is a world of quiet beauty, with vast canyons that dwarf the Grand Canyon, polar ice caps that wax and wane with the seasons, and ancient riverbeds that speak of a time when water flowed freely across its surface. It's a world that seems simultaneously familiar and alien, close enough that we've sent dozens of robotic explorers to study its secrets, yet different enough to remind us of the vast diversity of worlds that exist in our cosmic neighborhood. Orbiting Mars are two small moons, Phobos and Deimos, named after the Greek gods of fear and panic who accompanied Ares, the god of war, into battle. But despite their fearsome names, these moons are gentle, irregular-shaped bodies that tumble peacefully through the Martian sky. They are likely captured asteroids, dark and rocky objects that were gravitationally embraced by Mars sometime in the distant past. Phobos, the larger and closer of the two, is only about 14 miles across at its widest point, so small that if you could stand on its surface, you could literally throw a baseball hard enough to put it into orbit. As our journey continues through the contemplation of these cosmic relationships, we begin to understand the delicate gravitational dance that governs the motion of Phobos around Mars. This small moon orbits incredibly close to its parent planet, closer than any other moon in our solar system orbits its planet, while our own moon takes about 28 days to complete one orbit around Earth. Phobos races around Mars in just 7.5 hours, completing more than 3 orbits in a single Martian day. But here is where the story becomes truly fascinating and peaceful in its implications. Phobos is gradually spiraling inward toward Mars. The process is so slow that it's barely measurable, but it's as inevitable as entropy itself. Tidal forces, the same forces that cause our ocean tides here on Earth, are gradually sapping energy from Phobos' orbit, causing the moon to lose altitude at a rate of about 6 feet per century. This might seem negligibly slow, but in the grand scheme of cosmic time, it means that Phobos is doomed to either crash into Mars or break apart. Within the next 50 million years, let us drift into the contemplation of what will most likely happen to Phobos as it continues its slow spiral toward Mars. As the moon approaches closer to the planet, it will encounter the Roche limit, the peaceful boundary, where Mars' gravity becomes stronger than Phobos' own gravity. When this happens, Phobos won't suddenly explode or crash dramatically. Instead, it will begin to gently come apart, like a sandcastle slowly eroded by gentle waves. The moon's loose material will begin to separate and spread out along its orbital path, eventually forming a ring of debris around Mars. In the quiet space of scientific modeling, researchers have used computer simulations to visualize this process, and what they've discovered is both beautiful and serene. The breakup of Phobos would create a ring system around Mars that might persist for millions of years, gradually spreading outward and becoming thinner as the debris settles into stable orbits. The rings would be composed primarily of rock and dust, the same dark, carbon-rich material that makes up Phobos today, creating a subtle but distinct feature. Around the red planet, gently, we discover that the timeline for this transformation is both distant and immediate in cosmic terms. 50 million years from now seems almost impossibly far in the future. It is longer than the time that has passed since the asteroid impact that ended the age of dinosaurs, longer than the entire evolutionary history of grass and flowers on Earth. Yet in terms of planetary evolution, it's a relatively short period, equivalent to the last few pages of a very long book. The process itself would unfold with the same patient inevitability that characterizes all cosmic evolution. As Phobos approaches the Roche limit, it would begin to deform slightly, becoming more elongated as Mars' tidal forces stretch it. Small pieces of debris would begin to break away, the least tightly bound material escaping first. Over thousands of years, more and more material would separate, until eventually the moon would exist as a loose collection of rubble held together by its own weak gravity. As our journey continues deeper into this cosmic transformation, we can envision the gradual spread of this debris along Phobos' orbital path. The material wouldn't disappear or fall into Mars immediately. Instead, it would continue to orbit the planet, gradually spreading out to form a thin ring. The particles in this ring would range in size from tiny dust grains to boulders several yards across, all tumbling peacefully through space in the silence of the Martian environment. Now we float toward a visualization of what Mars might look like with its new ring system. Unlike Saturn's bright, icy rings that gleam brilliantly in sunlight, Mars' rings would be composed of dark, rocky material that would appear more subtle and subdued. From the surface of Mars, observers might see the rings as a faint band of light, stretching across the sky, visible primarily at dawn and dusk, when the sun's angle allows the ring particles to catch and reflect light back toward the planet's surface. The rings would likely be relatively thin and close to Mars, extending perhaps from just above the planet's atmosphere to several thousand miles out into space. They might be barely visible to the naked eye from Mars' surface, appearing as a gossamer thread stretched across the heavens, growing brighter and dimmer as the planet's rotation brought different portions of the ring system into view. During dust storms, which can engulf the entire planet of Mars, the rings might become completely invisible, only to reappear as the atmosphere cleared. Let's drift into the contemplation of how these rings might change with the Martian seasons. Mars has a tilted axis similar to Earth's, which means it experiences seasons, though each season lasts about twice as long as Earth's seasons due to Mars' longer year. The appearance of the rings would change throughout the Martian year, sometimes appearing more edge-on from certain locations on the planet's surface, other times presenting a broader face that might catch more sunlight and appear slightly brighter. In the quiet space of comparative planetology, we can imagine how Mars' rings might compare to the ring systems we observe around other planets. In our solar system, Saturn's rings are composed primarily of water ice, which makes them highly reflective and brilliant white when viewed through telescopes. Jupiter's rings are made of small dust particles kicked up by micrometeorite impacts on its small inner moons, creating a tenuous, gossamer system that's barely visible even to spacecraft visiting the giant planet. Uranus and Neptune both have ring systems composed of dark particles, more similar to what we might expect from Mars. Uranus rings are made of chunks of dark material, possibly organic compounds altered by radiation, while Neptune's rings consist of dust particles that may come from its moon Triton. These ring systems serve as gentle reminders that planets and their moons exist in dynamic relationships, constantly exchanging material and energy in processes that unfold over millions of years. As our journey continues through the implications of Mars gaining rings, we must also consider what this might mean for future human exploration of the red planet. By the time Mars develops its ring system, humanity will have had 50 million years to evolve, explore, and perhaps even establish permanent settlements throughout the solar system. If humans are still present in the solar system at that time, they would witness one of the most spectacular natural transformations in planetary history. The presence of rings around Mars would create both opportunities and challenges for future space travelers. On one hand, the rings would provide a spectacular view for anyone living on or visiting Mars. Imagine watching the ring system slowly wheel overhead, creating subtle patterns of light and shadow as it occults distant stars. The rings might also serve as a source of raw materials for construction projects, providing easily accessible rock and metal for building structures or spacecraft. On the other hand, the ring system would create a navigation hazard for spacecraft approaching Mars. The debris in the rings would represent a collision risk, particularly for fast-moving vessels arriving from other parts of the solar system. Future Mars missions would need to carefully plot their trajectories to avoid the densest portions of the ring system, or perhaps develop new technologies for safely traversing debris fields. Now we float toward a deeper understanding of the scientific methods that have allowed researchers to make these predictions about Mars' future. The study of planetary ring systems is a relatively young field in astronomy, having begun in earnest only in the 1970s and 1980s when spacecraft first visited the outer planets and discovered that rings were much more common than previously thought. Saturn's rings had been known since Galileo first observed them through his primitive telescope in 1610, but the discovery that Jupiter, Uranus, and Neptune also possessed ring systems came as a surprise to many scientists. The prediction that Mars might develop rings is based on careful observations of Phobos' orbit, combined with theoretical models of tidal evolution and gravitational dynamics. Using precise measurements of Phobos' position over many years, astronomers have been able to calculate the rate at which the Moon is spiraling inward toward Mars. This observational data, combined with computer models of how moons break apart when they encounter the Roche limit, allows scientists to predict not only when Phobos will break apart, but also what the resulting ring system might look like. Gently, we discover that these predictions represent a beautiful example of how modern astronomy combines observation, theory, and computation to understand processes that unfold over time scales far longer than human experience. The scientists studying Mars' future rings are essentially cosmic archaeologists working in reverse. Instead of studying the debris of past events, they are predicting the debris of future events, based on the gravitational forces and orbital mechanics they can observe today. The computer simulations used to model Phobos' breakup are marvels of scientific computation, incorporating thousands of variables including the gravitational effects of Mars, the Sun, And Jupiter, the internal structure and composition of Phobos, and the complex dynamics of how debris spreads out after a moon breaks apart. These simulations require some of the most powerful computers in the world, running for weeks or months to model processes that will unfold over millions of years. In the real universe, as our journey continues into the realm of deep time, we begin to appreciate the patience required to understand cosmic evolution. The transformation of Mars from a ringless planet to a ringed world represents just one chapter in the ongoing story of planetary evolution that has been unfolding for billions of years throughout our solar system. Every planet, every moon, every asteroid is part of this grand celestial dance, slowly changing and evolving under the influence of gravitational forces that never rest. Let us drift into the contemplation of what other changes might occur in our solar system over the same time span that Mars develops its rings. 50 million years is long enough for significant orbital evolution. Throughout the inner solar system, Earth's moon will have moved several thousand miles farther away from our planet, making it appear noticeably smaller in the sky and reducing its influence on our tides. Venus will have completed hundreds of millions of rotations in its slow, backward spin, while Mercury will have orbited the Sun more than 200 million times in its rapid 88-day cycle. The outer planets will have changed much less dramatically over this time span, their vast distances from the Sun making their orbital periods much longer, and their evolution much slower. Jupiter will have completed only about 850 orbits around the Sun, while distant Neptune will have moved less than 1/6 of the way around its 165-year orbital path. Yet even these giant planets will not remain unchanged. Their moons will continue their own complex gravitational dances, and their ring systems will evolve as particles settle into new configurations or are lost to space. In the quiet space of this extended cosmic time frame, we can also contemplate what might happen to Mars' other moon, Deimos. Unlike Phobos, which orbits close to Mars and is spiraling inward, Deimos orbits much farther out and is actually slowly moving away from Mars, gaining energy and altitude in the same way that our own moon is gradually receding from Earth. This means that while Phobos is doomed to destruction, Deimos might survive for billions of years, becoming a distant, solitary sentinel orbiting high above Mars' new ring system. The contrast between the fates of these two moons illustrates one of the beautiful complexities of celestial mechanics. How identical objects can experience completely different evolutionary paths, depending on their orbital characteristics. Phobos, orbiting close to Mars, experiences strong tidal forces that drain energy from its orbit and pull it inexorably inward. Deimos, orbiting farther out, experiences much weaker tidal forces that actually add energy to its orbit, pushing it gradually outward into space. Now we float toward a consideration of how the formation of Mars rings might affect the planet's climate and atmosphere. While the rings themselves would be relatively thin and composed of dark material, that wouldn't significantly alter the amount of sunlight reaching Mars' surface. Their presence might have subtle effects on the planet's atmospheric dynamics. Ring particles might occasionally fall into Mars' atmosphere, creating brief meteor showers that could be visible from the planet's surface. The rings might also interact with Mars' magnetic field, though the planet's magnetic field is much weaker than Earth's and exists only in patches, rather than as a global phenomenon. Charged particles in the solar wind might become trapped or deflected by the ring system, potentially creating very faint auroras visible from certain locations on Mars' surface. These auroras would be much dimmer and less spectacular than the northern and southern lights we see on Earth, but they would represent a new type of atmospheric phenomenon for the red planet. As our journey continues through the scientific implications of Mars' future transformation, we must also consider how the formation of rings might affect our understanding of planetary evolution throughout the universe. Mars would become an ideal natural laboratory for studying ring formation and evolution, providing astronomers with a nearby example of a process that likely occurs around planets throughout the galaxy. The study of Mars rings would contribute to our broader understanding of how planetary systems evolve over time. By observing the breakup of Phobos and the subsequent formation of rings, scientists would gain new insights into the processes that shape planetary systems throughout the universe. This knowledge would be particularly valuable for understanding exoplanets, planets orbiting other stars, many of which likely have their own complex systems of moons and rings that we cannot yet observe directly. Let us drift into the contemplation of how Mars transformation might inspire future generations of scientists and explorers. The gradual formation of Mars rings would unfold over a time span that encompasses thousands of human generations, creating an ongoing natural experiment that could be studied and documented by countless researchers over millennia. Each generation would contribute new observations and insights, building up a comprehensive picture of ring formation that would be impossible to obtain from studying the already formed ring systems around other planets. The presence of rings around Mars might also inspire new forms of art and literature. Just as Saturn's rings have captivated human imagination for centuries, future poets might write verses about the subtle beauty of Mars' dark rings, wheeling silently overhead, while artists might create paintings or sculptures inspired by the interplay of ring shadows and Martian landscape. The rings might become a symbol of the ongoing transformation and evolution that characterizes all things in the universe. In the quiet space of philosophical reflection, the story of Mars' future rings invites us to consider our own place in the vast sweep of cosmic time. The transformation that will create Mars rings will unfold over a time span so long that it dwarfs all of human history. Yet it represents just a brief moment in the evolution of our solar system. This perspective can be both humbling and inspiring, reminding us that we are part of something much larger and more enduring than our individual lives, or even our species' existence. Gently, we discover that contemplating such vast time scales can actually be deeply comforting, providing a sense of perspective on the temporary nature of our daily concerns and worries. The universe operates according to natural laws that unfold with patience and inevitability, creating beauty and complexity through processes that require no anxiety or stress, only time and the gentle persistence of physical forces. As our journey continues into the deeper implications of cosmic evolution, we begin to appreciate how the formation of Mars rings connects to broader themes in astronomy and planetary science. Ring systems appear to be a natural and common feature of planetary systems arising whenever the conditions are right for moons to venture too close to their parent planets, or for other objects to be captured and broken apart by gravitational forces. The study of ring systems has revealed that they are dynamic, evolving structures rather than permanent features. Saturn's rings, magnificent as they appear today, may be relatively young in cosmic terms, perhaps only a few 100 million years old, and they will eventually dissipate as their particles either fall into the planet or escape into space. This means that ring systems come and go throughout the history of planetary systems, appearing and disappearing on time scales of millions or billions of years. Now we float toward a consideration of how the timing of Mars ring formation relates to the broader evolution of our solar system. 50 million years from now, the Sun will be slightly brighter and warmer than it is today, as it continues the gradual brightening that characterizes main sequence stars throughout their lives. This increased solar output might help to warm Mars slightly, though the planet will still be much colder than Earth due to its greater distance from the Sun and its thin atmosphere. The other planets will continue their own evolutionary paths during this time. Earth's continents will have moved measurably due to plate tectonics, creating new mountain ranges and ocean basins. The Moon will appear smaller in Earth's sky as it continues to recede from our planet, making total solar eclipses rarer and eventually impossible as the Moon becomes too small to completely cover the Sun's disk. Venus will continue its slow rotation in the thick, crushing atmosphere that makes it the hottest planet in the solar system. The extreme greenhouse effect on Venus will persist, maintaining surface temperatures hot enough to melt lead despite the planet's greater distance from the Sun than Mercury. The slow evolution of Venus's atmosphere over millions of years remains one of the great mysteries in planetary science. Let us drift into the contemplation of how Mars ring formation fits into the even longer-term evolution of our solar system. Over hundreds of millions of years, the rings around Mars will gradually spread outward, and become thinner as tidal forces and radiation pressure from the Sun cause the ring particles to either fall back to Mars or escape into interplanetary space. Eventually, Mars will likely lose its rings entirely, returning to its current ringless state but forever changed by the experience. This cycle of ring formation and dissipation may repeat multiple times throughout Mars' future history. If Mars captures new small moons from the asteroid belt or if large impacts on its surface kick up debris that becomes temporarily trapped in orbit, the planet might develop new temporary ring systems that last for millions of years before dissipating. The history of Mars over the next billion years might include multiple episodes of ring formation, each one unique in its characteristics and duration. As our journey continues through these vast timescales, we begin to appreciate the cyclical nature of cosmic evolution. Nothing in the universe remains static forever. Even the most seemingly permanent features are constantly changing and evolving under the influence of physical forces that operate with infinite patience. Mountains rise and erode away, continents drift and collide, stars are born and die, and planets gain and lose rings in an endless cycle of transformation. In the quiet space of this cosmic perspective, we can find a deep sense of peace and wonder at the processes that shape our universe. The formation of Mars rings represents just one small part of the vast, ongoing experiment in complexity and beauty that the universe has been conducting. For billions of years, every planet, every star, every galaxy participates in this grand cosmic dance, contributing its own unique variations to the theme of evolution and change. Gently, we discover that the story of Mars' future rings also illustrates the power of scientific predictio and understanding. The fact that astronomers can look at the current state of Mars and its moons and predict what will happen 50 million years in the future demonstrates the remarkable consistency and predictability of natural laws. The same gravitational forces that govern the motion of falling apples also determine the fate of moons and the formation of planetary rings. This predictive power of science provides a deep source of comfort and wonder, revealing that the universe operates according to comprehensible principles that can be studied, understood, and used to make accurate predictions about future events. While we cannot predict the detailed behavior of complex systems like weather or ecosystems very far into the future, we can make remarkably accurate predictions about astronomical events because the forces involved are well understood and the systems are relatively simple. Now we float toward a consideration of what other surprises the solar system might hold. For future astronomers, the transformation of Mars from a ringless to a ringed planet will be just one of many changes that will occur over the coming millions of years. Other small moons throughout the solar system are also slowly spiraling toward their parent planets, potentially creating additional ring systems around planets that currently have none. Jupiter's small inner moons, for example, are constantly being bombarded by micrometeorites that kick up dust particles, feeding the planet's faint ring system. Some of these moons may eventually be completely eroded away by this process, their material joining Jupiter's rings and making them slightly more prominent. Similarly, some of Saturn's small moons may meet similar fates, contributing new material to the planet's already spectacular ring system. The outer solar system holds particular promise for future ring formation. Many of the moons of Uranus and Neptune orbit relatively close to their parent planets, and may eventually succumb to tidal forces, creating new ring systems or enhancing existing ones. The complex gravitational interactions between these planets' many moons create a rich environment for orbital evolution and potential ring formation. As our journey continues into the realm of comparative planetology, we can appreciate how Mars' future rings will contribute to our understanding of ring systems throughout the universe. By studying ring formation around a nearby planet, astronomers will gain insights that can be applied to the interpretation of ring systems around distant exoplanets. While we cannot currently observe rings around planets orbiting other stars, future telescopes may develop the capability to detect these features, opening up an entirely new field of exoplanetary astronomy. Let us drift into the contemplation of how the presence of rings affects the habitability and atmospheric evolution of planets. While Mars' future rings are unlikely to significantly affect the planet's climate, Ring systems around other planets can have important effects on their atmospheric dynamics and surface conditions. Ring particles can shadow portions of a planet's surface, creating complex patterns of heating and cooling that affect atmospheric circulation. Ring systems can also interact with planetary magnetospheres, trapping charged particles and affecting the radiation environment around a planet. For planets with substantial atmospheres, ring particles that fall into the atmosphere can create meteor showers and contribute trace amounts of various elements to the atmospheric composition. These effects are generally subtle, but they represent additional factors that must be considered when evaluating the habitability of planets with ring systems. In the quiet space of astrobiological speculation, we might wonder whether ring systems could ever contribute to the development or evolution of life on a planet. While the direct effects are likely to be minimal, ring systems do create unique environmental conditions that might influence evolutionary processes over very long time scales. The complex patterns of light and shadow created by ring systems might affect photosynthetic organisms, while the meteor showers caused by ring particles entering the atmosphere might contribute to genetic diversity through increased mutation rates. Gently, we discover that these speculations about rings and life illustrate the interconnected nature of planetary systems. Every component of a planetary system, the star, the planets, the moons, the rings, the atmospheres, influences every other component in subtle ways that become apparent only when we consider the system as a whole over very long periods of time. The formation of Mars rings represents just one thread in the complex tapestry of our solar system's ongoing evolution. As our journey continues through the implications of Mars transformation, we must also consider the technological challenges that ring systems might pose for future space exploration. While Mars rings will be relatively sparse compared to Saturn's dense ring system, they will still represent a navigation hazard for spacecraft approaching the planet. Future mission planners will need to develop new techniques for safely traversing ring systems, possibly including advanced radar systems for tracking debris and sophisticated trajectory planning, algorithms for finding safe paths through the rings. The presence of rings might also affect communication between spacecraft and ground controllers on Earth. Radio signals traveling between Earth and Mars already experience delays of several minutes due to the vast distance between the planets, and the presence of ring particles in the signal path might cause additional interference or signal degradation. Future communication systems might need to be designed with greater redundancy and error correction capabilities to maintain reliable contact with Mars-based missions. Now we float toward a consideration of the opportunities that Mars rings might provide. For scientific research and exploration, ring systems are natural laboratories for studying the physics of particle dynamics, orbital mechanics, and gravitational interactions. The formation and evolution of Mars rings would provide researchers with a unique opportunity to study these processes in detail using spacecraft and instruments positioned throughout the Mars system. The rings might also serve as stepping stones for future exploration of the outer solar system. Ring particles could potentially be harvested and used as raw materials for spacecraft construction, or as reaction mass for advanced propulsion systems. The relatively low velocity of ring particles compared to interplanetary trajectories might make them easier to capture and utilize than asteroids or other sources of raw materials. Let us drift into the contemplation of how Mars rings might affect the cultural and psychological experience of future Mars colonists. Should humanity establish permanent settlements on the Red Planet, the presence of rings overhead would create a unique sky unlike anything experienced on Earth, providing a constant reminder of the dynamic nature of planetary systems and the ongoing processes of cosmic evolution. The rings might serve as a natural calendar or clock, their changing appearance throughout the Martian day and year, providing reference points for timekeeping and seasonal observations. Different locations on Mars might have distinctly different views of the ring system, creating unique local identities and cultural traditions based on the appearance of the rings from each settlement. The gradual changes in the ring system over decades and centuries might also provide long-term continuity for Mars-based civilizations, creating shared reference points that connect different generations of colonists. just as people on Earth use the phases of the moon and the changing positions of stars to mark the passage of time and seasons. Future Martians might develop cultural traditions based on the slow evolution of their planet's ring system. As our journey continues into the realm of cosmic timescales, we begin to appreciate how Mars ring formation connects to even larger patterns of evolution throughout the universe. The processes that will create Mars rings are examples of the same fundamental forces that shape galaxies, create and destroy stars, and drive the overall evolution of the cosmos. Gravity, the force that will slowly tear apart Phobos and create Mars rings, is also the force that holds galaxies together and drives the formation of planetary systems around other stars. In the quiet space of this cosmic perspective, we can see how the story of Mars rings illustrates the unity of physical law throughout the universe. The same principles of orbital mechanics that govern the motion of Phobos around Mars also govern the motion of planets around stars and stars around the centers of galaxies. The mathematics that astronomers use to predict the breakup of Phobos are fundamentally the same as those used to understand the formation of spiral arms in galaxies or the merger of black holes. Gently, we discover that this unity of physical law provides a deep source of comfort and wonder, suggesting that the universe is fundamentally comprehensible and that the same processes we can study and understand in our own solar system are at work throughout the cosmos. The formation of Mars rings becomes not just a local curiosity, but a window into the fundamental processes that shape all of reality. Now we float toward a consideration of how the timing of Mars ring formation relates to humanity's potential future in space. 50 million years is an almost incomprehensibly long time. From a human perspective, longer than our species has existed, longer than complex multicellular life has existed on Earth. Yet, if humanity manages to survive and spread throughout the solar system and beyond, there is a possibility that future humans or their descendants might witness the gradual formation of Mars rings. This raises profound questions about the continuity of human civilization and knowledge over such vast time scales. Will the scientific understanding that allows us to predict Mars ring formation today survive for 50 million years? Will there still be recognizably human observers to witness the breakup of Phobos and the formation of the rings? These questions touch on some of the deepest philosophical issues about the nature of consciousness, civilization, and the long-term future of intelligence in the universe. Let us drift into the contemplation of how the study of Mars' future rings illustrates the power of scientific imagination and theoretical modeling. The astronomers who predict Mars ring formation are essentially time travelers, using their understanding of physics and mathematics to peer far into the future and describe events that will not occur for millions of years. This ability to transcend the limitations of direct experience and explore possibilities beyond the present moment represents one of the most remarkable achievements of human intelligence. The computer simulations used to model Phobos' breakup and ring formation are marvels of scientific visualization, creating detailed movies of events that will unfold over millions of years. These simulations allow researchers to explore different scenarios and test their understanding of the physical processes involved. They represent a form of experimental science conducted entirely in the realm of computation, where hypotheses can be tested and refined without waiting for the actual events to occur. As our journey continues through the methods and implications of astronomical prediction, we begin to appreciate the careful balance between confidence and uncertainty that characterizes scientific forecasting over long time scales. While astronomers are quite confident that Phobos will eventually break apart and form rings around Mars, many details of this process remain uncertain. The exact timing, the precise appearance of the resulting rings, and the specific dynamics of the breakup process all depend on factors that are not perfectly known. This uncertainty is not a weakness of the scientific method, but rather an honest acknowledgement of the limits of current knowledge and the complexity of natural systems. By explicitly quantifying and discussing these uncertainties, scientists provide a more accurate and nuanced picture of what the future might hold. The prediction of Mars ring formation comes with error bars and confidence intervals, just like any other scientific measurement or calculation. In the quiet space of scientific humility, we can appreciate how the story of Mars rings illustrates both the power and the limitations of human understanding. We can predict the broad outlines of what will happen to Phobos over the next 50 million years, but we cannot predict the exact details of every aspect of the process. This balance between knowledge and uncertainty is characteristic of all scientific endeavors, from weather forecasting to cosmological modeling. Gently, we discover that this uncertainty actually adds to the wonder and beauty of the story rather than detracting from it. The fact that the universe still holds surprises and mysteries, even in processes that we understand quite well, ensures that future generations of scientists will have new discoveries to make and new questions to explore. The formation of Mars rings will undoubtedly reveal details and phenomena that current models cannot predict, providing new insights into the physics of ring formation and planetary evolution. Now we float toward a consideration of how Mars transformation connects to broader themes of change and continuity in the natural world. The breakup of Phobos and formation of rings represents a fundamental change in Mars' appearance and characteristics, yet it occurs through the same gravitational processes that have been shaping planetary systems for billions of years. This illustrates a deep principle of natural evolution, that dramatic changes often result from the gradual accumulation of small effects over long periods of time. The same principle applies to many other natural processes, from the evolution of life on Earth to the formation of mountain ranges and ocean basins. What appears stable and permanent on human timescales often reveals itself to be dynamic and evolving when viewed over longer periods. The Grand Canyon, carved by the slow but persistent action of the Colorado River, represents the same kind of gradual transformation that will eventually give Mars its rings. As our journey continues through these themes of cosmic evolution, we can appreciate how the study of planetary ring formation contributes to our understanding of change and stability throughout the universe. Ring systems themselves are examples of dynamic equilibrium. They appear stable when viewed over short periods, but are actually in constant flux as particles settle into new orbits, collide with each other, or are lost to space. This balance between apparent stability and underlying change characterizes many natural systems. Let us drift into the contemplation of how the formation of Mars rings might inspire new ways of thinking about time and change in human affairs. The 50 million year time scale of ring formation dwarfs all of human history and requires us to think beyond the immediate concerns of daily life. This cosmic perspective can be both humbling and liberating, providing a framework for understanding our place in the larger scheme of things. The patience required for natural processes like ring formation offers a different model for approaching human challenges and goals. While we cannot and should not ignore immediate needs and concerns, the cosmic perspective reminds us that some of the most important and lasting changes require persistence and patience over long periods of time. The gradual accumulation of scientific knowledge, the slow development of wisdom and understanding, and the patient work of building sustainable human societies all benefit from this longer-term perspective. In the quiet space of this cosmic time scale, we can find a sense of peace with the pace of natural change and the rhythm of universal evolution. The universe is not in a hurry. It has all the time in the world to create beauty and complexity. Through the patient application of simple physical laws, there is something deeply comforting about this unhurried pace. This cosmic patience that allows for the gradual unfolding of complexity and wonder. Gently, we discover that the story of Mars rings offers a meditation on the relationship between the immediate and the eternal, the local and the cosmic, the familiar and the unknown. Mars, our nearest planetary neighbor and the subject of countless science fiction stories and exploration missions, will undergo a transformation that connects it to the broader family of ring planets in our solar system. This transformation bridges the gap between the worlds we know well and the more exotic realms of the outer solar system. As our journey continues toward its conclusion, we can reflect on how the prediction of Mars ring formation represents a triumph of human curiosity and scientific understanding. From ancient observations of Mars as a wandering red star to modern spacecraft missions that have revealed the planet's detailed geography and atmospheric dynamics, our understanding of Mars has grown through centuries of careful observation and analysis. The ability to predict what will happen to Mars 50 million years in the future represents the culmination of this long tradition of Martian studies. It demonstrates how scientific knowledge builds upon itself, with each generation of researchers adding new observations and insights to the accumulated understanding of previous generations. The prediction of Mars rings stands on the shoulders of countless astronomers, physicists, and planetary scientists who have contributed to our understanding of orbital mechanics, tidal forces, and planetary evolution. Now we float toward our final contemplations of this remarkable cosmic story. The transformation of Mars from a planet with 2 small moons to a world adorned with rings represents just one chapter in the ongoing evolution of our solar system. It reminds us that the universe is not a static, unchanging place, but rather a dynamic system where new beauty and complexity are constantly being created. Through the patient application of natural laws, the rings that will eventually grace Mars will be different from those of any other planet. In our solar system, darker and more subtle than Saturn's brilliant ice rings, closer to the planet than the gossamer rings of the gas giants, and composed of material with its own unique history and characteristics. These rings will be Mars' unique contribution to the diversity of ring systems in our solar system, adding a new variation to the theme of planetary rings that we see throughout the cosmos. In the quiet space of our final reflections, we can appreciate how the story of Mars rings connects us to the vast sweep of cosmic time and the ongoing evolution of the universe. The same processes that will create Mars rings are at work throughout the cosmos, shaping planetary systems around other stars and contributing to the ever-changing tapestry of cosmic structure and complexity. The formation of Mars rings represents a future milestone in the history of our solar system, a transformation that will occur long after our current civilization has passed into history, yet which we can envision and understand through the power of scientific reasoning and imagination. It stands as a testament to the human capacity to transcend the limitations of direct experience and explore the vast realms of space and time through the tools of science and mathematics. Let's drift into our final moments of contemplation, appreciating the profound beauty and peace that emerges from understanding our place in this vast cosmic story. The rings that will someday grace Mars remind us that we're part of something much larger and more enduring than our individual lives or immediate concerns. We are participants in a universe that creates beauty and complexity through the patient application of simple, elegant laws. A universe that has all the time in the cosmos to unfold its wonders. The prediction of Mars rings also reminds us of the continuity between past, present, and future. The same gravitational forces that shaped the early solar system for and 500 million years ago continue to work today and will continue to shape planetary systems for billions of years to come. We are witnesses to and participants in this ongoing cosmic evolution, connected to both the ancient history and the distant future of our solar system, through the universal laws of physics that govern all matter and energy. As we prepare to conclude our gentle journey through this cosmic story, we can carry with us a sense of wonder at the patience and persistence of natural processes, the power of scientific understanding to reveal hidden connections and predict future events, and the profound beauty that emerges from the simple interactions between gravity, matter, and time. The rings that will someday adorn Mars stand as a symbol of the ongoing creativity of the universe, a reminder that new beauty and complexity are always emerging from the patient workings of natural. In these final moments of our cosmic meditation, we can rest in the knowledge that we are part of a universe that operates with infinite patience and wisdom, creating beauty and complexity through processes that require no anxiety or stress, only time and the gentle persistence of physical forces. The transformation that will give Mars its rings proceeds with the same unhurried grace that characterizes all cosmic evolution, reminding us that the universe has all the time it needs to create wonders beyond our imagination. The story of Mars' future rings offers us a glimpse into the deep future of our solar system, while also connecting us to the timeless principles that govern all cosmic evolution. It stands as a beautiful example of how scientific understanding can reveal the hidden connections between apparently separate phenomena and illuminate the profound unity that underlies the apparent diversity of the natural world. As our cosmic journey draws to its peaceful conclusion, we can appreciate how the contemplation of Mars' future transformation has carried us through vast realms of space and time, from the immediate dynamics of Phobos' orbit to the cosmic principles that govern planetary evolution throughout the universe. We have explored the patient timescales of astronomical change, the subtle beauty of ring systems, and the profound connections between local events and universal processes. The rings that will someday grace Mars serve as a meditation on the nature of change and continuity in the cosmos, reminding us that even the most dramatic transformations unfold through the gradual accumulation of small effects over vast periods of time. They represent a future milestone in the ongoing evolution of our solar system, a transformation that connects Mars to the broader family of ringed worlds while maintaining its own unique characteristics and history. In the gentle darkness of space, where these cosmic processes unfold with infinite patience, we find a model for approaching our own lives and challenges with greater equanimity and perspective. The universe teaches us through examples like Mars' future rings that the most profound and lasting changes often require patience, persistence, and faith in processes that unfold over time scales far longer than our immediate experience. Good night from the sleepy scientist.